Alright, sorry about last week,
Oh,
or
no
last
problem.
Wednesday.
No problem. I had a very busy Wednesday anyway. I didn't mind having one less appointment.
Alright. So, I was wondering if we could do the California method today. Would that
Okay. You're going to have to tell me what it is.
the one for factoring.
No, I know it. You're going to have to tell me what it is. I'm not
Okay.
familiar with it.
Okay, let me see if I can find my notes. So, I think it's when you use,
Let's start with a polynomial, and then we'll see if we can figure out how to do it.
what are you doing? Okay.
Here, how about this one here? Okay. So is the California method the one where you draw the boxes?
No, it's the one with the fractions.
Just not
Yeah.
familiar with it.
Okay. My teacher said that we're going to start it Monday, so.
Well, let's cover something else then, because she'll be able to cover that with you.
Okay. Then I was wondering if we could just do more factoring, because
Okay.
I need practice with that.
Okay.
Yeah.
Do you have a bunch?
I don't have problems this week, no. My teacher's been giving us worksheets, but we didn't have homework over the weekend.
Okay. I've got some. Let me open to my chapter on factoring. I've been doing a lot of this, actually. Everybody's on factoring, and nobody has lots of problems. Well, and I don't know, I might have done some of these with you already. I suppose it doesn't really matter. We'll start with easy ones.
Okay.
The California method might work better on harder ones. I don't know. It's hard to imagine that anything works easier than my method on easy ones.
Okay.
Help me out here.
So X goes in the first one, and second one too. And then you would put, multiplies to -8, so positive 4 would go in, no, -4
Okay.
would go in another box.
Why don't we take it one step at a time? You're trying to combine two steps in one.
Okay.
Okay? This is the first step, X and X. The second step is because that's negative, these signs are opposite. Okay?
Okay.
Now the third step is factors of 4 that subtract, because of that, to the number 2. Not -2, but to the number 2. So
Okay.
those factors would be
4 and 8. 4 and 2, sorry.
4 and 2. And then take the larger factor and put it with the sign of the middle term. So where's the 4 go?
In the second box.
That's my method. And I can't imagine the California method's easier than that, or quicker. It might be with more complicated ones. But when I say easy ones, I mean all ones that start with x squared. In other words, as long as it's an x squared, my method's going to work really well. Let me do another couple here. Now, are you given to them in this format also? Or are they given to you like that?
We haven't had them yet, but wouldn't you just add the 49 to the other side?
Yeah, in other words, I was going to do that. I didn't know whether. So this is also easy because it's just, there's no coefficient in front of the squared term.
Okay.
What's the second step?
You put the signs are going to match.
Okay.
And be negative.
Okay.
Negative matches.
Now the third step.
The factors of 49 that add to 14.
That add, because of that plus, to the number 14. Okay, so what are they?
7 and 7.
Okay.
What would you do if there was a coefficient in front of the squared term?
Okay, let's do one of those. Well, the thing we know is that the first two terms have to multiply together to give you that term. So how do you want to break it up? In other words, we need to factor 2x squared.
Okay. So 2x and then an x?
Always. Never 2x squared and 1. In other words, always put at least one of the variables there. Okay? Now that changes everything. Doesn't change the second step. The second step is still the same. What's the second step say?
That you have to figure out which signs go where and where.
Well, it means the signs are opposite. Examining that negative sign means the signs are opposite.
Okay.
But in this case, plus minus isn't necessarily the same as minus plus because of those different coefficients. Okay, so I want to allow for both possibilities. I know that it's either plus minus or minus plus. The same thing holds true when I have this. It's just that plus minus is the same as minus plus. There's no difference. So I only have to put plus minus. But the moment I have a coefficient in front of one of the x's, then it matters. So I have to allow for everything. Now I'm kind of on trial and error. I'm looking for factors of 3, but I can't say that they have to subtract to the number 1 or anything like that. I can no longer make those statements. But how many factors of 3 are there?
1.
So 3 and 1.
Yeah.
Now what I do from here is I start trying them randomly. I start with 3 and 1. Does that work?
Yes.
Yes, it does. But let's say I hadn't gotten so lucky. And let's say that I would have started with 1 and 3 instead. That doesn't work. So now I'm going to try the 1 and 3 down there. That doesn't work. So now I'm going to try the 3 and 1 up there. That works. And my last thing I would have had to try if that didn't work was the 3 and the 1 down there. In other words, I got 4 possible combinations I can try. And it's possible the California method helps you out there. I don't know. But this is the way I've always done it. Usually in a problem like this, they're not going to give you a whole lot of factors of this number here, because that just means that it would create even more possibilities.
Okay.
And they won't give you a lot of factors of that either. In other words, it's unlikely you're going to get a question like this, because that would take us all day to do, because we could have 3x and 4x. We could have 6x and 2x. We could have 12x and x for possible factors of that. And then the same thing over here. We can have 12 and 1, 6 and 2, 4 and 3. So we would have to try all combinations of all of these until we found one that gave us this correct middle term.
Okay.
Okay? And if the California method makes a problem like this easier, by all means let me know and I will learn it and start teaching it to people. I'm not sure I ever learned it. It's one of many methods taught. And I went to school I went to like a different school every year, so I learned lots of different methods for factoring and came up with this one, and this is the one I teach students how to do. This is the one that's kind of trial and error. It's not trial and error as long as it's, you know, just an x squared. It's pretty straightforward. Let's try one more here. Goes here and here.
Okay. So you have to have 3x and 1x in one box. And then the signs are the same and they're both positive.
Which makes it easier. That eliminates one of the choices that we might have to make. In other words, if they're opposite, that means there's more possibilities. Now our only choices are either 3 there and 1 there, or 1 there and 3 there. Which one works? Which one works?
3 in the first box and 1 in the second? No.
No? Does that work?
No, it doesn't. So you have to have 1 in the first box and 3 in the second.
Okay. Let me see if I can challenge you a little bit more here. This one looks kind of interesting. I swear I will try not to use variables of t, because they look like plus signs.
I guess it'll have to be 11m and 1m because there's not really another.
You're right. That's the only factors.
Yeah, and then the signs are going to be opposite.
Okay, so so I need to do a plus, minus, and also consider that it might be minus plus, which is going to be different. Now, lots of factors of 16. Let's list them.
16 and 1, 2 and 8, 4 and 4.
Okay. So, let's start trying them. Now, before we go further here, it's not totally trial and error at this point. I know for sure that I can't have a 16 over here, right?
Yeah, because of the 11. Because
it would produce a huge number. So we can eliminate that choice.
Okay.
And in fact, if I have a 16 on the left, that combined with 1 is going to give me either plus or minus 5m. So I can eliminate that.
Okay. So then you only have 4.
So now I don't have to consider that possibility. What I tell people is always start with the 2 closest factors, because that's usually the answer. But it's real clear here to know that 4 and 4 is not going to work either, because 4 times 11 is going to be 22. Combined with 4, there's no way I'm getting back to 18. So 4 can't be it. So we're down to 2 and 8. It's obviously not going to be the 8 over here, because that would make too big of a middle term. So 8's got to go here, 2's got to go there. Aha, 8m and 22m do subtract to 14, so I just have to get it in the right manner. Where's the 8 go, and where's the 2 go?
The 2 would have to go in the second box?
Yeah, in other words, like this. Well,
Yeah.
not just in the second box, but with the plus sign.
Yeah.
In other words, because now we have minus 8m plus 22m, 14m. Okay, so that was hard to do, but not quite as hard as it might have been. In other words, it wasn't like we had to check. We could rule out 2 of the possible factors pretty easily. And sometimes that's how you have to do these. You don't have a Texas Inspire, do you? The new CX?
Yeah, I do. Not
Really?
with me. It's in my classroom. Yeah, that's our school's requiring it this year for all geometry and above for classrooms.
Yeah, everybody is. I shudder to think, though, because that calculator, I've been playing with it for 2 weeks. I just got one myself. And it'll do everything.
Yeah.
Everything. It'll factor all of these things that we're going to factor by hand here. It'll do it. Which means, at what point in time will you be able to go through college, get an engineering degree, and not know how to do any of these manually? Because will you ever have to really know how to do these manually?
Yeah, it's funny though with the calculators. When we were going through some of our lines unit and things,
Yeah.
it was difficult because he would say, "Okay, do this on the calculator," and I would look at the calculator and I'm like, "There's so many buttons, I don't know how to."
Well, it's a very difficult calculator to use, and that's the complaint I've heard from a lot of kids.
Yeah.
They hate it because it's so hard, and it's so different than the one before it. It doesn't work like the TI-84 at all. And it is hard, and that's why I'm wondering. I'm guessing they're allowing its use because they don't care if you're smart enough to figure out how to do it manually, like we're doing, or if you're smart enough to figure out how to do it on your calculator. I guess they figure that they're equally good.
I know there's this one, but I did it by hand because I couldn't figure out how to work the calculator, and the answer was right, but my teacher marked it incorrect because I didn't use the calculator.
Really? Wow. Wow. Well, if nothing else, I look at it as an exercise in intellectual advancement. In other words, being able to do these manually as opposed to the calculator trains your mind to think in a certain way. And when you get to really high math, where you have to set up a problem and not just solve it, your mind needs to be trained in that way. So I do think there's a downside. It's kind of like having to depend on a calculator to do multiplication and division and addition and subtraction. It slows you down so much when you're solving algebraic equations if you can't do that stuff in your head. Well, I think the same thing kind of applies. But, okay, so here, what should we try?
2W and 2W?
That's always where I would start.
And 1W.
If it doesn't work, then we'll have to go back and try 4W and W.
Yeah.
Okay. Now what?
The signs are going to be opposite, and the larger number is going to be negative.
Well, yep. But notice I don't have to write plus minus on this side now, because it's the same thing. In other words, because these coefficients are both 2, then it's plus minus or minus plus, but they're not distinguishable. So I don't have to account for it. Now the only thing I need to account for are factors of 27. What are they?
27 and 1, 9 and 3.
That's it?
I think so, yeah.
Now, is 27 and 1 a possibility?
No.
Because one of these numbers would be 54W. No way we're getting it back down to 13W. So, let's try 9 and 3. I can either put the 9 here and the 3 here, but you said the 9 goes with the negative. Does that work?
Negative 18. Yeah. Yes?
No. 18 minus 6 is 12.
Oh, so you'd have to have the positive 9 and then the negative 3.
No.
Oh.
Notice that if I do that, same thing. In other words, it doesn't matter. I still have 18 minus 6. That's what I meant, that it wouldn't matter whether it's plus minus or minus plus. So 9 and 3 do not work with 2 and 2. So go back. Let's try 4 and 1. Now, because these coefficients are different, it most definitely matters whether it's plus minus or minus plus. Now we have to allow for the differences.
Okay, so then you have to start again with the...
Yeah, 27 and 1 still aren't going to work, because even if I have the 27 there, I got 27W minus 4W, no way I'm getting back to 13. Okay, and if I put the 27 over here times 4, that's 108W. So I can rule that out. So we know it's 9 and 3.
And then your 9 would have to be 36. I don't know what that is. I think, would the 3 have to go in the first? No.
Hold on a moment. I'm trying to figure out if I copied this problem wrong. Ah, yes. The instructions are factor this, and if it cannot be factored, say so. This cannot be factored. There's no, sorry about that. I didn't mean to throw one in.
Okay.
But no matter whether I do that, notice that 9 and 12 don't add or subtract the 13. And 9, 36, and 4 don't add or subtract the 13. So this doesn't factor. We've tried all combinations. So what's our next thing to do? If we have this as an equation and it says solve it, normally we would solve it by factoring it and letting each one equal 0 and solve each one. But what do we do if it's not factorable?
Quadratic equation?
You remember what it is?
Negative b plus or minus the square root of 4a minus
b squared.
b squared minus 4ac over 2a.
Okay. Let's plug in. And that's what w is going to equal. W, you're going to have two solutions for w. One of them is going to be the plus, one of them is going to be the minus. So what's minus b?
That would be positive 13. Right?
Mm-hmm.
Plus
What's
or
b
minus,
squared? 13 squared, I think it's 169 if I'm not mistaken.
I believe so.
Okay. Minus 4 times a times c. What are a and c?
4 times negative 27. So 112, I think.
The net of this is 1? No, it can't be 112. What's 4 times 27?
4 times 27 is 432. Right? Am I right?
16 times 27 is...
I don't know, my calculator times 27. Yeah, 432.
Okay, so we have 169. Notice it's a plus because it's minus minus. So far we have this. What's 2a?
8.
Okay. So, what is 169 plus 462?
601.
Which means we're going to have an irrational answer. So my 2, and I knew that when it didn't factor. The fact that it doesn't factor means you're always going to have an irrational answer. So my final answer, it's probably best to split these into 2 fractions. So W is going to equal 13 over 8 plus square root of 601 over 8, or W is going to equal 13 over 8 minus square root of 601 over 8. So those are your 2 solutions for that equation. If we plug them back in, we will see that that becomes a true statement. Now, I may have taken you beyond what you've had up to this point. Have you ever gone through a full quadratic formula like that?
Not in class yet, but we did it last, so.
Okay, well that's basically the process that one's always going to do, is you're going to try to factor it first, and if you can't factor it, you always go to the quadratic formula. In other words, it's still solvable, it's just the answer doesn't lie with integers. Alright, well, I didn't really intend to give you one that couldn't be factored. I knew that we were working on factoring, I just didn't read the instructions well enough.
I have a question. In my book, we haven't talked about it in class, so I don't know, but I've noticed it says, you know, factor if at all possible, and then it says something in the directions about prime factors. It's like, if it's a prime factor, say so. What does that mean?
Okay. What's the definition of a prime number?
A number that can only be multiplied by itself in 1.
Look,
factors are self.
Can only be divided by itself in 1.
Yeah.
In other words, the number 7 is prime, because nothing else divides into it. 7 divides into it, and 1 divides into it. Okay? So, if I took the number 28, and I said break it into its prime factors, well, we know that it's 7 times 4. 7's prime, so that's 1 prime factor, but 4 isn't. 4 is 2 times 2. So the prime factors of 28 are 7 times 2 times 2. In other words, every number you end up with is going to be a prime number. Now, give me the prime starting from 2. 2 is the first prime.
2, 3, 5, 7, 11, 13, 17, 19, right? 20, 21.
Oh, that's good. That's a good start. That's about how far everybody can get. And then figuring them out for bigger numbers is far more difficult. In fact, I watched a show yesterday that was amazing about prime numbers. They go to infinity, and yet, if you wanted to find a string of numbers that it went 8 billion numbers without coming across a prime, you could. And in fact, if you want to find a string of numbers of any length that you want, you can find it, and there will be that many numbers between primes. Once you get up to big numbers, there can be 2 numbers between a prime, there can be 5 numbers between primes, there can be 5 billion. And the science of figuring out the pattern of primes is really quite interesting. They say the secrets to mankind are held in determining the answer to that. It's considered the #1 problem in all of not just math but science, is proving something called Riemann's hypothesis, which is all about prime numbers. But we digress. What else do you want? You want to do some more factoring?
Yeah.
You want me to show you how to factor on your calculator? Let's not. Let's make sure you get factoring down before we give you that little bit of magic.
Okay.
Okay. Let's do this one. Because I have to believe that it's still a requirement.
Okay. So, would you start with 3m and 3m?
I would. I can't be certain that it's that, but I would start with that.
Okay. And then you know the signs are going to be the same and negative.
Huh. Okay.
And you have to multiply to 25 and add to 30.
No, remember you can't say that any longer.
Well, yeah, but
You can only make those statements if this is m and m. The moment there gets to be a number in front of one of these, you can't say, you can definitely say factors of 25. In other words, it has to be two numbers that multiply to 25. But you can say nothing with regards to the 30. We can only try them. So what would be the two obvious ones to start with?
the audio being weird. So you have 25 and 1 and 5 and 5?
Uh-huh. Remember, always start your first trial. Start with the two closer ones. Does that work?
Yeah.
Okay.
Um,
All right. Factoring can come a little differently also. Let's look at another. Now, before I immediately draw my parentheses here, I'm presented with a problem. The biggest problem is this negative sign in front of the b squared. I don't like having to handle that, because if I all of a sudden start putting negative b and 3b, now I got different combinations of those that I can use. It just complicates it severely. So my first step that I always want to do is have a positive exponent in front of my b squared. Well, what can I do here to get a positive exponent? Or not exponent, but a positive sign.
you can multiply by -1.
Yeah, I can do it to both sides of the equation. It doesn't change the zero. So I can immediately do this. Now it makes it a lot easier conceptually. I'm used to dealing with positive exponent or coefficients. But again, it would be 3b and b, and then I got all the problems that go with that. Is there anything I can do before to make this problem easier?
You put -1 to distribute.
How about if I factor out a 3? In other words, I can factor out a greatest common factor of 3. And the beauty is that it leaves b squared. That's what I want, is no coefficient in front of that. In other words, this becomes much easier to factor than the other would have been. I'm going to get the same answer regardless. Don't misunderstand that. There's multiple ways of doing stuff. But now, since I've factored out the 3, I only have to factor this into two things. Well, this is pretty easy. B and B. What else?
And then you have to get, you can do this now. So it has to be opposite and negative has to be bigger.
Uh-huh.
And then it's going to add to 90.
Not add.
Or multiply to 90.
Subtract. And not 90. We're looking for factors of 30 now.
30,
that subtract, because of that minus sign, to the number 1.
Okay, so it would be, so you could pull out a
What are factors? Well, look for factors of 30 that subtract to 1.
5 and 6?
Yeah, 10 and 3 don't.
Yeah.
So it's got to be 5 and 6.
Hi, this is the first number. Please leave your name, number.
Okay.
So we know the 6 has to go there, because you said the bigger factor's got to go with the negative sign. The 5 goes there, and now we have fully factored that thing. That's the final answer.
What? Sorry, the audio's being...
I said now we have fully factored that.
Okay.
That
And
is
then when
the final
you-
answer. Huh?
The 3, would you distribute only to the first set of parentheses?
If I wanted to distribute it, I don't necessarily have to distribute it. If I'm solving this equation, then I can divide now both sides by 3 and get rid of it. And then B is either equal to minus 5 or B is equal to 6. But had I done it the other way, had I done it without factoring the 3 out, what I would have gotten was this. Just would have taken a lot longer to get there.
Yeah.
Multiply these two together, you still get the original equation. You still get the same answers. B is still equal to minus 5 or B is equal to 6. So it changes nothing. And this final thing is not fully factored because I can still take a 3 out. So I would have to fully factor it. If the question is fully factor, you always have to factor it all the way down. You can't leave it with still factors that can be pulled out. So this is my final answer regardless of how I do the problem.
Okay.
If the question is to fully factor. If the question is to solve the equation, my final answer is B equals minus 5 or B equals 6. You get that part, right?
Yeah.
Okay. Okay. Let's talk about a couple of other quadratics that are a little different, that don't involve factoring. How about this? Solve this. It involves factoring, but not factoring in the way that we've been factoring using the, I won't call it the California method. It's probably not. And I'm kind of curious to hear what the California method is. Maybe you can finally teach it to me.
Yeah.
So what can I factor out of here? When you're factoring, always look for a greatest common factor to begin with.
Okay. So 4 would be one, right? 4A?
Yep, 4A, exactly. What's left behind?
An A squared? Or just an A and a 1.
Okay, well, the plus 1, what goes here?
10A?
Uh-huh. So, if that's equal to 0, what are my solutions? Remember, quadratics almost always have 2 solutions. They can be the same, but usually they're not the same.
For this one, would you factor just the 10A and the plus 1?
No? In other words, it's fully factored. You can't factor it anymore.
So
The key here is, this is one of the most fundamental algebra points. What it says is that if you multiply in one entity by another entity and you get 0, one of these has to be 0. You can't multiply two numbers together and get 0 unless one of them is 0. You can't multiply three numbers together and get 0 unless one of them is 0. So once we have stuff factored, the whole point of factoring is because we now have it this times this. So I can now say, well, either 4a is equal to 0 or 10a plus 1 is equal to 0. Well, what's the solution to that?
Just, well, would it both be, yeah, for both of them.
A would have to be 0 to solve that. What's the solution for this one?
It would have to be, like, what the heck?
Minus 1/10.
Minus, yeah.
Subtract 1 from both sides, divide by 10. So this had two solutions. And notice that if we go back to the original equation and we put 0 in for a, sure enough, that works. 0 plus 0 equals 0. But it also works if we put in minus 1/10 for a. That also becomes true. So whenever you're getting two solutions, as long as you're doing simple polynomial equations like we're doing now, both solutions are going to be correct. It's the moment you start adding radical signs or absolute value signs or logarithms, now when you get two solutions, it's very likely that one of them could be extraneous and not be correct. And so at that point, you have to start checking both solutions back into your original equation. And if one doesn't work, throw it out. Remember, the principle says that only one of these things has to be equal to 0, not necessarily both. So it's entirely possible that one might be 0 and the other might not be. Okay.
So, is it... So when you pull out the greatest common factor from them, that's also a solution to the quadratic? Is that, no?
No, notice that that doesn't really affect anything.
Not necessarily?
No, it doesn't. In other words, the fact that there's a 4 in front of this a didn't change the solution. A is still 0. Even if this was 14 or 114, a would still be 0. Because the only way that a number times a variable can be equal to 0 is if the variable is 0. So in the same way earlier when I pulled out that 3, it didn't really affect the solution at all. The solution was still laid in that and that, setting each of those equal to 0, or doing that, which gave the same answer, and that. So pulling out the 3, like I said, I could have divided both sides by 3 and got rid of it completely. It merely has to do with making it a little easier to factor by hand. And it also depends on what the problem is. If the problem is solve this equation, then that's a different problem than factor this expression. If in the previous problem here, the question was factor this expression, then the final answer is this: 3 times b plus 5 times b minus 6. If the question is solve the equation, the final answer is b equals minus 5 and b equals plus 6, and the 3 doesn't really have much to do with it.
Okay.
All right.
So,
Let's do a relatively easy one. Well, let's look at it from a slightly different angle here. let's look at this. This is a quadratic. Even though there's no n term, it's still a quadratic. You recognize this expression as anything?
No.
Well, it's difference of perfect squares. Remember what
okay.
a squared minus b squared factors into?
Isn't it a plus b and then a minus b?
Uh-huh. Well, in our case here, we have an a squared. It's just that a is 9n. So I could say a equals 9n, b equals 4, and then I have a squared minus b squared. So this would factor into 9n minus 4 times 9n plus 4. Now I can solve that by setting each of those equal to 0. So here n is going to equal 4/9. Here n is going to equal negative 4/9. Okay? So that's one way to solve it, by factoring it. And if you recognize difference of squares, it's helpful. You're going to run into a lot of difference of squares. It's really helpful to recognize it. The one that's hardest to recognize is this one right here. Because you don't tend to think of 1 as being a perfect square number. But it is. This factors into x minus 1 times x plus 1. Okay? Most cases, when you get a problem that's difference of squares, it'll be this format here, where this quantity is a perfect square of something, and that is a perfect square of something. Let's do this problem in a different way. It's almost easier as long as you remember to do one thing. What would the normal way you would do this problem be?
Like normal as in not the
Like
formula?
in algebraic. If I just gave you this algebraic equation to solve and I didn't tell you we were talking factoring or anything, what would your first step be?
To add 16 to both sides.
What would your second step be?
To divide by 81.
So now we have n squared equals 16 over 81, which actually becomes 4/9 when simplified. So now what's the final step? N equals what?
The square root of positive or negative 4/9. Right?
Positive or negative the square root of 4/9.
Yeah.
Excuse me, I made a mistake. This does not reduce to 4/9. We'll leave it at 16/81. And now to solve this problem, we take the square root of both sides. And the square root of 16 is 4. The square root of 81 is 9. So n equals 4/9, but it's plus or minus 4/9. In other words, if we solve this the normal way, half the time people are going to forget that plus or minus there. So they would come up with a solution of n equals 4/9. But notice that when we solved it by difference of squares, we got plus 4/9 and minus 4/9 because we had 9n minus 4 times 9n plus 4. So that gave us n equal plus 4/9 and n equal minus 4/9. So doing it by factoring it like it was difference of squares ensures that you get both solutions. I'm not sure why, but one of the hardest things to remember for students in math is that when I solve this problem, what's x equal to?
Positive or negative 16 or 4. 4.
Right.
Yeah.
90% of my students will leave that off if you ask them that. I probably would leave it off at least 30% of the time. It's just very hard to remember that there's always that plus or minus that you have to put in front of there. All right. We got time for maybe one more thing. Let's see if I can find something interesting that's a little different than what we've done. One last problem. Solve the equation.
Okay. Oh lordy. Okay. So you'd have to make one side 0, right? To start?
Wouldn't have to in this case, because if you try gathering like terms, nice things will happen. You could do it the other way. You could move everything over to one side, works just as well, gives you the same answer. Go ahead and pick one method. I'll go with it.
I guess moving everything over is probably what I would do.
Okay, so what do we have on the left after we move everything over to the left?
You have p squared minus 49
Equals
0.
now what?
You add 49 and then take the square root of that. So you get p is equal to negative or positive 7.
Good. Notice I could have done the same thing as I did with the last problem when I got to this step here. I didn't have to take the 49 to the other side. I know how that factors because that's difference of perfect squares. P plus 7, P minus 7. And now that means P is equal to minus 7 or P is equal to plus 7. So I get the same answer either way.
Okay.
All right. Well, that should be helpful to you. If you're just starting quadratic factoring tomorrow, we've done quite a bit of it here.
Okay.
Okay?
All right, thank you.
Good luck. I will talk to you Wednesday.
Thanks.
All right. Bye-bye.
See about the California method.
Yes, you'll be able to teach me it.
Okay.
Bye-bye.
Bye.